In today's lesson, we are going to be looking at factoring trinomials part 2 when a does not equal 1. So this is going to be a different set of, or a different method to factoring a trinomial compared to what we learned previously, because we are going to be given a different kind of format. So when trinomials are in the form ax squared plus bx plus c, where a does not equal 1, they produce binomials that are px plus r times qx plus s. So this is going to be a little bit different from what we've seen, because in the previous lesson we saw r or x plus r and x plus s, but here we now have something additional, which is that p and q. So there's going to be a value in front of our x terms in our brackets when we factor. And if I take a look at those two brackets, if I expand them, or use the distributive property to expand them to work backwards to see, okay, where do I see these components coming out in my trinomial? So if I multiply the first two, I get p times q x squared. We'll kind of color code it. So we'll have p q, pq, so p times q and then x squared. And then we're going to have p times s with an x plus q times r q times r with an x. And then finally, plus r times s. So where do these components come from in when we're looking at our general form, that ax squared plus bx plus c? Well, we should remember from before, the two middle terms are going to add together to make our bx, or b. So that means basically ps and qr have to add up to give us b, and rs is going to give us our c value. Now it's a little bit different though, because how do I get p and s and q and r? Right? So there's a little bit more here in this. It's a little bit more complex than what we've seen. But essentially what we're looking for is again two values, and the two values have to multiply to a times c, and the same two values have to add to b. So there's a new thing that we're looking for. So we're looking for two values that multiply to a times c, and they add to b. So it's a little bit different because of how this works out, how we expand. And we're going to use the method of decomposition. So we're going to work through it slowly. So again, the first step is, for our product, we're looking for two numbers that multiply to not 3, but 2 times 3, or 6. So two numbers that multiply to 6, because we have a times c, 2 times 3, so two numbers that multiply to 6, and they still add to that middle value, that sum of 5. So what two numbers multiply to 6 and add to 5? Well, in this case, we have 2 and we have 3. Now, this is going to be a little bit different. Right? It's going to be a little bit of a different method. We're going to keep the first term, 2x squared. We're going to break up the middle term into two separate terms. One will be 2x, and the other one will be plus 3x. So basically, I'm just breaking down that 5x into two different terms, positive 2x and positive 3x. Because if I add 2x and 3x, they both add together, they add to 5x. So it's still the same thing. And then I'm going to have the plus 3 on the end. Now what we're going to do is we are going to factor the first two terms and the last two terms, and we're going to factor them separately. And when we're factoring these two terms, we're essentially just looking for a common factor. So a common factor from 2x squared and 2x is 2x itself. That would leave me with x plus 1. And our goal when we common factor the second pair is to end up with the same bracket. And we'll see why in a second. So if I common factor the next two, I can take a positive 3 out of both. That would leave me with x plus 1. Now I have something that's similar to what we've looked at previously when we common factored. I have a common bracket. So I can actually common factor that bracket out, x plus 1. And what's left over in my second bracket, or what's left over makes up my second bracket. So this all works out to x plus 1 times 2x plus 3. So it is a little bit different, and this is what we call decomposition. We're breaking it down, we're decomposing that middle term into two separate terms, then we're doing some common factoring to get down to our final factored form. So a few more steps going through the process, and definitely a different beginning step of the numbers that we're looking for, and we're kind of breaking it down. So let's look at the next one. 2x squared plus 5x plus 2. Right, so again, I'm looking for two numbers that multiply. So two numbers that multiply 2 times 2. Right, the first number times the last number, a times c, or 4. And the two numbers that multiply to 4, they also have to add to 5. So what two numbers multiply to 4 and add to 5? Well, it's a little bit easy. That's 4 and 1. So that means I'm going to break up my middle term into 2x squared plus 4x plus 1x and then plus 2 at the end. Because 4x plus 1x is 5x. So I'm breaking up that middle term. Next, I'm going to common factor the first two terms and the last two terms. So common factoring 2x squared plus 4x, I end up with 2x. That leaves me with x plus 2. In my second bracket, I can't really factor anything out. I could factor out, though, I could just say plus x plus 2. Leave that as its own, right? There's nothing really else we can factor. But we should see that we have a common factor of a bracket. So I'm going to have x plus 2 as a common factor come out, and the remainder will be 2x plus this invisible 1 here. So I'll have 2x plus 1 as my second bracket. And that's how we factor these trinomials where the a value is not 1. So we're just going to look at a few more examples just so you can get comfortable with this. So I want to factor 3x squared plus 7x plus 2. So for my product, I'm looking for two numbers that multiply to 6, which comes from 3 times 2, or my a times my c value. And in the sum, they have to add up to 7. So two numbers that multiply to 6 but add to 7. In this case, we have 7 and 1. So now I'm going to break up this middle term into, well, I'll keep my 3x. We'll keep the 3x squared. We'll have 7x plus 1x, and then we'll have the plus 2 on the end. It doesn't really matter what order you put these in. Either way, it's going to work out. We're going to go through, common factor the first two terms. common factor the first two terms, I end up with, I can't really take anything out of the first one except for an x. Oh, wait, no, I did this wrong. Because if I go back, I should be able to factor something if it's factorable. I made a mistake of putting 7 in 1 instead of 6 in 1. So now that's a little bit easier. So hopefully you caught that mistake. You can consider it a little test. Now there is more I can factor. I can factor out a 3x, which will leave me with x plus 2. And then in my second bracket, again, nothing I can really factor out here. So I'm going to leave the bracket, I'm going to leave it as just plus x plus 2. We could say, well, I factor out a 1, which is fine because that will help us with the next part. And then finally, I have a common bracket, x plus 2 that I can take out, and then my leftovers, 3x plus 1, make up my second bracket. Next example, 2x squared plus 7x plus 6. Again, we're looking for two numbers that multiply or give us a product of 2 times 6 or 12. And the same two numbers have to give or add to 7. In this case, again, 4 and 3. So that means I'm going to break up my middle term. So I'll start off by writing out my first term because that's not going to change. That middle term is now going to be a plus 4x and a plus 3x. And then I'm left with plus 6 at the end. We're going to common factor the first two terms and the last two terms. You don't need to show all these symbols. I'm just kind of showing this to give more, to kind of help be more visual for when you're working through these. So if I factor the first two, I can take out a 2x. I'm left with x plus 2. And in the other one, I can take out a plus 3 and be left with x plus 2. Again, our goal when we common factor the second pair is that we end up with the same bracket as the first, which we do. In both, we have an x plus 2, which we can common factor out. And then we're left with 2x plus 3 as our remaining, or our second bracket. More examples, again, going through, same idea, just different scenarios, different signs, different types of numbers. So two numbers that multiply to -6, or 2 times -3, and they have to add to -5. It's a little bit more challenging, right, because we're dealing with some negatives here. But looking through it, it's -6 and +1. So I can break up my middle term of 2x squared. Instead of -5x, I'll have -6x and plus 1x and minus 3 at the end. Common factor, my first two terms. I end up with 2x that I can take out, and I'm left with x minus 3. And in my second bracket, there's nothing I can factor out, so I'm just going to put a plus 1. And it'd be left with x minus 3. I don't really need to show the plus 1, but again, I'm just doing that for the next step to make it a little bit easier, and because there is technically an invisible 1 there. We should find that we have a common bracket, so I can take that bracket out, x minus 3, and then 2x plus 1, the leftovers, make up our second bracket. Again, same type of example, going through D, same type of situation. Two numbers that multiply to 12, or 3 times 4, and add up to -8. Again, it might be a little bit more challenging, but the more we do this, the more we know our times tables, the more comfortable we get. -2, or -6 and -2. Those both multiply to +12 and add to -8. So again, we're breaking up our middle term. So we're breaking it up. Instead of -8, we can write -6x and -2x. The plus 4 will still be at the end. I'm going to look to common factor my first two terms and my last two terms. I can common factor out a 3x and get x minus 2. And here's where it can be a little bit tricky. If I look at the second pair, right, we might say, okay, well, I can factor out a 2. Right, so I can factor out a 2 and be left with negative x plus 2. However, that's not the same bracket. And in order to continue, we want to make sure that we end up with the same bracket. Now, the only difference between these two brackets here is the sign. One has a negative x and one has a positive. One has a negative 2, one has a positive 2. So the only difference is they're the exact same, except the signs are different. So if that's the case, then chances are we actually need to go through and factor out a negative value. So I'm going to factor out a negative 2 in this case and be left with x minus 2. And we could think, going back and looking up at this negative 2 up here that I've highlighted, generally we would want to have the value in front of x to be a positive or a positive 1. So that means we would have to factor out the negative 2 to make sure that that x became a positive. So different things we can do, but again, our goal is to make sure that we have the same bracket. So if we have different brackets, chances are we've taken out the wrong common factor. Now that I have the same brackets, I can remove that as a common factor or factor it out. And then the remainder, 3x minus 2, is my other factor. So just to summarize, right, because this one is a little bit more complicated, just so we can think of the steps. So to summarize, first we have to multiply a by c. And then we have to find two numbers that multiply to whatever the product of a times c is, and that they also have to add to b. So this last part is the same as the other trinomials, but this first part, multiplying to a times c, this is different. Once we find those two numbers, we're going to split bx, or the middle term, into those first two numbers, right? So the two numbers that we found, we're going to split that middle term up into those two numbers. Then what we're going to do, we're going to common factor the first two terms. We're going to common factor the second two terms, or the last two terms, and then we're going to common factor the common bracket. And once we go through that, the result should be our factored form, or the full expression factored. So again, a little bit more complex in these scenarios. These ones tend to be a little bit more challenging because it's not as straightforward. Or people tend to forget that we can't factor it the same as a simple trinomial or a trinomial where the a value is 1. So make sure you are comfortable with these steps. Make sure you can recognize when to use this new form of factoring for these trinomials. Now, if you remember from the last lesson of factoring simple trinomials, or when a is 1, we did have some scenarios that looked like a complex trinomial, or we did have some scenarios where the a value was not 1. However, we could still common factor and then turn it into one of those simple trinomials. So in this case, none of these initial expressions were able to be common factored, but again, that is something you should always look for. You should always look to see, can I common factor first to make it easier on myself? It may just be to make the numbers easier. Maybe you go from a complex trinomial with larger numbers to a new common factor to still a complex trinomial, but you have smaller numbers. Or maybe you factor it something like we did last lesson, where we take it from looking like a complex and factoring it so that it is a simple one. So again, a lot of this just comes from a lot of practice. Like anything else, you do have to practice this. The more you practice, the more you'll be comfortable with these steps, and the more you'll start to recognize the patterns and probably a lot of the factors or the numbers, right? Once you know the times tables a little bit more.